Hello everybody, and welcome to this video on how to fill in an EICR form. This video goes along with the other videos on the EIC and the video on the garage rewiring that we did. And obviously, just to remind everybody, this was an EICR that the client requested after I was called in to survey a previous electrician's work, and obviously he'd been asked to leave. I don't know why. So this is an EICR that's been a long time coming. Unfortunately, it got interrupted when I broke my thumb. I couldn't finish it, and obviously we had to wait for the installation of the isolator as well. So have a look at the videos that are involved with the EICR. There's two parts to that. First part deals with the visual inspection and the work that I actually managed to do with the Conservatory. Second part is the completion of the EICR I did yesterday, which deals with all the testing and the main part of the house. So I hope this is informative, and let's get to it. So here's the EICR form. Hopefully it's visible this time. It was a bit small on the last video for doing the EIC, so I've enlarged it, so hopefully people can see it this time. Anyway, the first part of the form is identical to the EIC, so same type of fields are filled in, so we will just skip over this bit. So it's a domestic property, and we'll just click on the next to go to the next bit. So we'll just come down here, and this is where it slightly changes. So we've got to do a summary of the condition of the installation. So in my opinion, the installation was satisfactory. There were a few problems, but they'll be detailed in the report. Over here we've got extent and limitations, so it's all of the electrical work except the work that I did, which was brand new, so that was done separately to this, so that's not covered in this EICR. Doesn't need to be, it's in the EIC. The loft and the inside of the walls are not expected. That's a usual thing. Sometimes you can go in the loft and do a bit of just have a look around. You're not expected to go bash holes in walls and things like that to have a look and see what the cables are doing, so it is a limitation normally. So now we'll come down to this. Now we do know from the client that there were alterations or partial rewiring was done a few years ago. That's the reason why this report was done, because it was not done in a satisfactory way, at least not as far as the client was concerned. I was brought in to do a thorough look over, and you'll see what we found in the video and what goes in this report. The wiring that hasn't been changed is about 60 years old. This property was built 1930s, 1940s we reckoned, so that'd be about right. There are no records available. There's no inspections have been done in the past, so there's nothing to say there. So amended to the 2020 IET regulations, and I have put down a further inspection here to be done by the beginning of next year. There will be another inspection done when I've done all the remedial work, and then I'll issue a proper EICR. This one has failed, I might add, but you'll see why in a minute. And then there's my declarations there. Next page. So we have a TNCS system, as you've seen in the video, and so the protected devices are a 1361 type 2B at 100 amps. There's no other source of supply. It's an AC system. Number of phases is 1. Number of wires is 2. So now we come down to the supply parameters, which is down here. Now it's 230 volt supply. As you saw in the video, the perspective fault current was 0.739. That was the higher of the two readings. It's a 50 Hz nominal frequency. Now this bit, as I've mentioned, I made a bit of a faux pas when I did the external loop impedance test when I was getting 0.4, and then I got 0.33. I got 0.4 because I didn't disconnect the bonding to the water pipes, which is a very long earth cable, goes from one side of the house to the other. That is why I was getting such a large external loop impedance, because I was getting a parallel path on a piece of earth bonding cable that was probably getting on for probably 15-16 meters long. The So that was a bit of a faux pas on my part. So I disconnected that and redid the reading, and sure enough, 0.33. So yeah, that's the importance of making sure when you do the external loop impedance, or the ZE, make sure haven't got any parallel paths. It does muck up the readings. So yeah, anyway, that's what it is. It's 0.33. So, means of earthing for this property is at the distributor's facility. It's not a TT system. I didn't do the maximum demand, so that's a limitation. The main switch in the main consumer unit is that. It's a 6090-47.3 at 100 amps. 100 amp current rated, number of 2 poles 2. Voltage rating 230 volts, and it's in the main house. It's not an RCD. Then we come down to the conductors. So the earthing conductors, protective bonding conductors, and the supply conductors, all fine. And like I say, the water installation pipes, they've been verified. That's fine. There is no earthing to the gas or anywhere else. Not needed. So now we come on to the schedule of inspection. So let's run through the outcomes. It can be a pass, a not acceptable. If it's a C1 or a C2, that's a fail. A C3, that would still pass the inspection. An FI would also fail the inspection. Obviously writing down limitation and are not verified. Right, so let's run through this particular installation. So I've actually gone through and filled these all in already, just to save a bit of time on the video. So as you can see on this part of it, I've passed the service cable, the service head, the earthing arrangements, the meter tails, the metering equipment, and obviously now there's an isolator, so that's passed. It's not applicable for micro generators because there aren't any. So that's that bit. That was nice and easy. Earthing and bonding, that's I believe all passed. If you go all the way down through here, there's a lot to do through here. So that was all fine. There was nothing wrong with the earthing that I found. Now the consumer units, this is where we have got an issue. Adequacy of working space, that was fine. Security of the fixings, that's fine. So IP rating was fine. It's fine, but the fire rating is currently, it's actually a metal enclosure. It's not damaged. There is a main switch. The main switch works. The RCDs, yes, I did do the test button and everything else, but you'll see those in the results. That's all fine. Correct identification for the circuit details, they are now. Presence of an RCD 6 monthly test notice, yes, because I put it on. Non-standard mixed cable warnings, yes, because again I put that on. Presence of an alternative supply warning, there isn't one, so that's not applicable. Presence of other required labelling, yes, there is. Compatibility of protected devices, bases and other components correct on rating. No signs of unacceptable thermal damage, arc and overheating, that's fine. Single pole switching or protected device in line conductors, that's fine. And protecting against mechanical damage is fine. This is the bit where it didn't. And I'll quickly put up a picture in a second to show you why, but that's because the cables are going in different holes into a metal enclosure. That's wrong. So that is a C2. This is the major reason why this inspection failed. So that is what I've got to put right. The RCD is all passed. There's no SPD, so that's not applicable. That passed. There's no generating sets, so that doesn't matter. Again, generating sets doesn't matter, or it's not applicable, so doesn't matter. Final circuits, all these pass, so identification, cables correctly supported, connection of insulated live parts, non-sheath cables done, integrity of conduit and trunking systems. Actually, I'm going to put that down as non-applicable because there wasn't any. Adequacy of cables, yes. Coordination between conductors and overload protective devices, yep. Adequacy of protective devices, yes, that was fine. Putting the adequacy of circuit protective conductors, yep, that was okay. The wiring systems are appropriate, they are. Concealed cables installed in prescribed zones. That's a limitation because I couldn't see that. There's no way out unless I banged holes in the wall. I couldn't see it. Cables concealed under floors, above ceilings in walls, adequately protected against damage. Now, apart from being under the floor when I ran that cable, I couldn't see any of this. So I have put down it as a limitation. But as someone has actually pointed out, there is actually a cable under that floor, under the kitchen floor, which if you could get to it, you could consider it dangerous. You could consider it that it needs to be dealt with. Now, should that be a limitation, or should I put that down as a C? I'm going to put that down as a C3 actually, because of what I found under the floor. You can't actually get to it though unless you dig the floor up. Provision of additional requirements. So RCD's done. There's no mobile equipment. Yes, you can pass that because most of the interior walls are that, so that's fine. There are no walls with metal parts that I do know. Luminaires are fine. Provision of fire barriers, yes. There's no band 2 and band 1 cable segregation, so all of this is all not applicable. So termination of cables, yes, that's where I've actually gone behind sockets and checked as part of the visual inspection, so there were no problems I found except for this one. And you'll see that in the video, is that some of the sockets in the kitchen just didn't want to play ball, so they will need to be changed out. So that's why it's down as a C3. That's fine. Adequate working space, yeah, no worries there. Single pole switching, yeah, that's fine, no problem there either. So up in the bath and the showers, yep, that's fine, that was okay. There were no silver pels, so it's not applicable. There were no shaver sockets, so that's not applicable. There was supplementary bonding in the bathrooms, so that passed. Low voltage socket outlets, there were no socket outlets at all in anything, so I've passed it. I could have put down not applicable, but I've passed it. Suitability of equipment for external influence, IP rating, yeah, that's fine. That's basically talking about IP rated lights, that's fine. Suitability of control gear for a particular zone, I passed that, that's fine. Suitability of current using, yeah, that's absolutely fine as well. Okay, so we go on to this bit. So schedule a test, what's in here. So that was done, there's no earth electrodes, no volt drop was necessary on this. That was all done, and there was no AFDDs, thank God. So we'll go on to the next bit. So this is just the observations that have come up. So in brief, that's a C2, so it needs to be dealt with. These two are C3s. They can be dealt with, they don't have to be, that's up to the client. So now we come on to the tests. Now there are, as I've mentioned before, there are actually 3 distribution boards in this property now, but only 2 of them are actually going to be dealt with in this EICR. There's the main board and the board in the conservatory. So we'll deal with the main board first. So label that's the main house. I'll give it a designation of DB1, and there are 8 ways on that board, 8 usable ways. There are 2 spare ways, but I'm just going to deal with the ones that are actually connected up. Those I would fill in at the end, and we're using the values from the on-site guide for ZS. That's the tester that was used, and I will fill in the testing dates later on. Now I don't need to fill in this bit this time round because I'm dealing with a DB that is connected directly to the supply. This will be filled in when we do the conservatory one in a second. So that's the first DB. So best thing to do is go on to the circuit tests. Pre-filled in some of this stuff except for the test results. So we're going to do so I will drop this down and you'll see there are all the circuits that we're testing. So we're doing a cooker, the kitchen ring, the socket radial upstairs, the lights upstairs, the garage, the socket radial downstairs, the lights downstairs and the conservatory. Now these four, 1, 2, 3, 4, they're on one RCD, and these four are on the other RCD. So let's go down and see what we've filled in. So all the wiring types, bar one, are type A, PVC, twill and earth. The only one that isn't is the cable that connects the main house to the garage, and that's a type G. The reference method is 102, which means it's in the wall or in the ceiling. And in this particular case, there's only one point to this cooker. It's a 6mm cable, and a 6mm cable actually has a 2.5mm CPC. Anything from 6 and above doesn't have 1.5 CPCs. Okay. Disconnection time is a normal 0.4. So the overcurrent device for this one is a 6898 type B, and it's a 32 amp rating with a breaking capacity of 6 kiloamps. The RC operating current is 30, and the max ZS from 32 amp breaker is 1.1. This is a radial, so we're not worried about ring final information. So the R1, R2 details. So let's bring up my little pad here. These are all the results from this. These are all the results from the testing. So let's forget the RCD testing for the second. The cooker circuit had a reading of 0.1. So we'll put 0.1 in here. Now the insulation resistance test I did manage to do at 500 volts. So, and it was absolutely fine, as it should be, because this was done as a rewire not so long ago. So I'd be hugely surprised if you didn't do that. So that was absolutely fine. Polarity test was fine, and the maximum ZS would have been 0.1 plus the 0.33 we got for the ZE, so that's 0.43, which is well within the max ZS. So it passes, that's fine. So the RCD for this, because the cooker was on the right hand side, so we're looking at the right hand side RCD, the right hand RCD had a value of 37.2 and 17.6. So 37.2, and what did I say? 17.6. So that's that one dealt with. Come to the rings, I'll come to the kitchen ring in a moment, because that's a little bit longer to do. So let's do the upstairs radial. So the upstairs radial, again, type A, 102. There are 6 points on this circuit, and this is 2.5, 1.5. Again, 0.4 disconnection time. It's a 16 amp B type MCB. And a 16 amp MCB has a maximum ZS of 2.18. It isn't a ring, it's a radial, and the result for that radial is, I'll just look it up. The upstairs radial gave me a reading of 0.77. Now you'll notice on this one I did a insulation resistance test at 250 volts. The reason for that is in the upstairs socket circuit there were USB charging which I could not isolate. So to be safe I could only do it at 250, so that's why I've set it at 250 here. No problem with the readings, so I was quite happy with that. I couldn't do it at 500 because I could have risked damaging the components. So the maximum measured ZS here would have been 0.77 plus the 0.33, I believe that's 1.1, my math is correct, and that's well within that 2.18 for this particular type of circuit. Again, the RCD readings are identical, so 37.2 and 17.6. So that's that one done. Okay, let's move on to the next one. Let's do the lights next. Upstairs lights. Again, exactly the same time for the wiring. There were 5 lights connected. It's a 1.5 and 1 because it's a lighting circuit now, 1.5 mil. Again, same disconnection time, same types of overprotected devices, except this time it's a 6 amp MCB, and it's still the same braking capacity. Same operating current for the RCD. This time the ZS for a 1.5 mil. For a 6 amp MCB is 5.82 for the ZS. And the R1 R2 for the upstairs lighting circuit was 1.1. Add that to the 0.33 and we get 1.43, which is absolutely fine. I was able to do the insulation resistance test on the lighting circuits upstairs because there was no LED stuff, so it was absolutely fine to do that. I just took all the bulbs out, so that's fine. That came out at 500. And again, same readings for the RCD. Okay, that's all done. Okay, so that's all the circuits on that RCD. Like I said, we'll come back to that ring last. So move on to the garage circuit. Now this is the only one where the wiring type was different. And if you go all the way down to the bottom, type G is an XPLE cable. Okay, reference method is 1. It's just in fresh air. And only 1 point because it's the garage consumer unit. It was done in 4mm with a 1.5 CPC. 6898 B type B. Now, yes, I got that wrong in the EIC, which I've now corrected. It's a 40 amp circuit breaker, not a 32 that I stated. I made that mistake, so it's a 40. That brings the ZS at 0.87. And the R1 R2 for that garage circuit is 0.1. That's from the EIC that I did. Again, we know that we did the installation resistance for that. We did it as part of the garage installation. So the actual value here is 0.43. The RCD values are now on the left side. So these ones here. So it's 40.8 and 13.6. Okay, so that's that one done. So that's the garage circuit. So move on to the sockets on the downstairs radial. Okay, this is twin and earth, back to 102 for the reference method. There are only 4 points on this particular circuit. Again, we're down to 2.5, 1.5 on the twin and earth. Disconnection time 0.4, 6898 on that. And this radial circuit again is a 16 amp. Gives me a ZS maximum 2.18. The downstairs socket radial going to be reading 0.28. Now I was able to do the insulation resistance test without a problem, and that full reading with the 0.33 gave me a reading of 0.61. Oops, there we go, 61. And just to do the RCDs, is again, like I said, it's 40.8 and 13.6. And I did say 13.6, didn't I? Yeah. So that's what the RCD is for that one. So that's absolutely fine. No problems at all with that. Right, so we go to the next bit. And the downstairs lights. There are 6 downstairs lights, wired in 1.5 and 1, 6 amp rating, a maximum ZS of 5.82, and the reading I got for the downstairs lights I've lost it, 0.91. Again, I was able to do the insulation resistance on the downstairs lights, and here that's 0.33 added to that, which is for 1.24. Again, happy with that. And finally the RCD results, 40.8 and 13.6. And finally, the last one is the Conservatory, which is the line going to the Conservatory DB board, and type A wiring, so it's twin and earth. It's clip direct to that one, so it's a different reference method, so it's reference method C, and only 1 point because it's going directly to that other consumer board. It's done in 6mm with a 2.5mm CPC. It's on a 40 amp breaker, so it's got a maximum ZS of 0.87, and the reading I got from that was 0.1, which gives me a value of 0.43. Again, I was able to do an insulation resistance test on it, and it was absolutely fine. And as with all the others, it was a 40.8 and a 13.6 on the RCD. Okay, let's go back to the kitchen ring, because this is a little bit more involved. So first of all, let's go through the bits that we've been able to do. So the wiring type A, the method was 102. Now I put down 7 points. Now there were 4 in the kitchen, 3 in the other part of that room where the sofa was and the TV was, where I think that they are part of a spur from the ring. So there were 7 points in total. They're definitely on the same circuit breaker. Anyway, 2.5mm conductors, 1.5 CPC, disconnection time 0.4, type B, 32 amp rating with a 1.1 maximum ZS. So now we come down to this. Let's have a look. So in the kitchen, I took a reading of the R1, which is connecting the line to line on both ends of the ring, and that came out at 0.34, and it came out 0.34 for both the R1 oops, and the RN. So the R2 reading. So let's go back to my notepad, and you'll see that I have multiplied the 0.34 by 1.67 because of the CPC being 1.5, and that actually gave me a calculated value of 0.56. And if you saw in the video, the actual value was 0.59, which is absolutely fine, well within the well within tolerance. So let's put that value in, 0.59. Now you don't have to actually put down the R1RN reading, it's only the R1R2. So we'll come over here, but I did the R1RN because you do that to do the figure of 8 to prove everything is working. So the R1RN value calculated was 0.34 plus 0.34 divided by 4. So the calculated value should have been 0.17. The actual reading was 0.19. Absolutely fine. And then the reading we're going to put down on the form is 0.34 plus the 0.59, which is the reading we got here for the CPC, divided by 4. So the calculated reading should have been 0.2325. The actual reading was 0.23, as you saw in the video. So in here we put down 0.23, and then we add that to the 0.33 ZE, and we get 0.56, which is well within the maximum ZS. And then finally we're going to fit in the RCD readings for this, which is 40.8 and 13.6. That completes everything on that particular board. So now we're going to go to the Conservatory board. So we go over to DB2. Now we've already done the connection from the main board to this board, so we don't need to add it into here. We've done that already, so that already exists. It won't just be duplicating work. So the first thing we're going to do is, as you can see, there are two, if you remember from the video, there's two rings here. I don't know why. So we'll start with the washing machine ring, because that was the one that was a little bit more difficult to do because the length is so short. So we come down here and it's a type A. The washing machine ring was type C to it, although it was in, actually it's not type C, I've got that wrong in fact, because it was in conduit if I remember correctly. It's type B in fact. Do apologise, and there's only 1 point. And it was 2.5 and 1.5 for the conductors, 0.4 disconnection time, had a 32 amp rating, 6 amp braking capacity, and 1.1 ZS. So again we come down to the R1, Rn and R2 readings. So we came down here and the washing machine readings were 0.02. So we are going to put them in anyway. And the reading for the R1, R2 was 0.03. And the actual reading here was 0.01. So very, very tiny readings within the realms of the 0.05 error. So I've got to put them down, but that's what they actually are. The tester would not go down any lower than that. My guess is that the actual readings were way lower than that for such a short distance, but like I say, they've got to go in, which gives me a maximum ZS for that one of 0.34. Now the RCD for these two, the Conservatory is actually on the right hand side, so that's 37.2 and 17. Sorry, it's on the left hand side. So the Conservatory is on the left hand side, so it's 40.8 and 13.6. The RCDs on that one. So that's where we are with that particular ring, and we'll just do the other ring in the Conservatory, which was the Conservatory ring. Oh, the number of points on this one was, just adding it up, 1, 2, 4. So there were 4 points in there in the Conservatory, 2.5, 1.5 as usual, again 32 amp, 1.1 ZS, and we'll come to the readings for the Conservatory ring. Now I've got 0.14 for the line and the neutral. There we go. And the CPC came out at 0.23. The R1RN was 0.07, which we're not going to put down. The R1R2 came out at 0.09. Add that to the 0.33 ZE, and we're getting 0.42. And obviously, like I said, we've done the insulation resistance already. And we need to do the test, which is the left-hand circuit, 40.8 and 13.6. So that's that circuit done, and then we've got two more circuits to do. We have the exterior lights for the EICR had a fault. If you remember, they were actually causing problems. I wasn't getting good continuity, I wasn't getting good insulation resistance, so there are no values for the exterior lights because I couldn't do it. Now the exterior light has since been replaced, and when I do back to do the remedial work, I will be able to do the proper readings for that, and they will go in the new EICR, which will pass, and they will go in there. So we're leaving the exterior lights on this one, and we're going to do the normal interior lights. There were quite a few lights on this, as you probably saw. A lot of spotlights. I think there are 8 in total, if I remember correctly. Again, 1.51, and all the reference methods are there. And again, 6 amp rating, a 5.82 maximum ZS. This isn't a ring. The reading for the interior lights was 0.53. Add that to the ZS, the ZE rather, which was 0.33, gives a reading of 0.86. Can I just add that the reading from the other consumer board gave me the same ZE reading as the main board, and that's only because the board for the conservatory is literally the other side of the wall. The distance was negligible, so I would have been shocked if the ZE reading was any different. So it isn't, it was 0.33, so just in case anyone wonders about that, no, the reading was the same. So anyway, sorry, I digress. So 0.86, well within the ZS for this. So that completes the test sheets for both of those boards. So we can do a preview now of how the EIC looks. EICR looks. So here it is. So we'll go my address. And as you can see, all the different fields have been filled in as per normal. There's the ZE value, there's the amp value, and an unsatisfactory result there because we have a C2 in orange. Okay, and the other two are C3s. Those are the observations. So we come through here, and there's a list of all the observations. There's the C2. Keep coming down. And then we've got two lots of test results. So we've got one for the main board, which is there, as you can see, just one ring has got its results through there. And then we come down to the other board, and again we've got two results there for two rings. And that is it. That is all the EICR. So there you go. I hope that's been helpful. It's a lot to fill in when you're doing an EICR, let alone doing an EIC. As you notice, I made a few mistakes, which are easy to do when you're doing these sort of things, and I hope I've corrected all of them. I don't think I missed any mistakes out, and we'll see you on the next one.